Good morning students, this is Latif sir. In this video, today I will discuss about conductance of electrolytic solution. Conductance of electrolytic solution. Like metallic conductor, electrolytic solutions are also conductor of electricity. That is, they can conduct electricity due to presence of oppositely charged ions in solution. Electrolytic solution like NaCl, they can produce ions, oppositely charged ions in solution, and therefore they can conduct electricity. That is, they are conductor of electricity. And like metallic conductor, electrolytic solution also have some resistance. Okay, so every conducting material offers some obstruction to the flow of electricity, and which is called resistance. And the unit of the resistance is denoted by capital R. In class 10 you have already studied in class 10 physics about resistance. Okay, for metallic conductor, same formula for calculation of resistance for electrolytic solution. Okay, you have already studied this relation in class 10 for calculation of resistance of a metallic conductor. Same formula you have to apply to calculate resistance of a electrolytic solution. And resistance is the obstruction to flow electricity, and it is denoted by R, and it is measured in ohm unit. It is measured in ohm unit. So unit of resistance is ohm, and the resistance of an electrolytic solution is directly proportional to length or distance between two electrode. Here length means distance between two electrode, and the resistance is inversely proportional to the area of cross section of the electrode, where A is the area of cross section of the electrodes. So you can write R is equal to R proportional to L, and R inversely proportional to A. Okay, so resistance of a solution is directly proportional to length of distance between the two electrode, and resistance of electrolytic solution is inversely proportional to the area of cross section of the electrode. Okay, and combining these two relation, you can write R is equal to some constant into L by A, where the constant is rho, and rho is known as specific resistance or resistivity of the electrolytic solution. And what is the unit of specific resistance? Its unit is ohm meter. Okay, so rho is the specific resistance. Now see, what is conductance? The inverse of resistance is known as conductance. So conductance, which is denoted by capital G, is equal to 1 by R. Inverse of resistance is known as conductance, and the unit of conductance is ohm inverse, or it is also written as mho. Ohm inverse means mho. Okay, and in a SI system, the unit of conductance is Siemens, and it is denoted by capital S. Okay, so Siemens, it is the SI unit of conductance, and one more unit of conductance is mho, or ohm inverse. Now see conductivity. What is conductivity? It is denoted by capital it is denoted by small k. What is conductivity? It is the inverse. It is the inverse of resistivity, inverse of rho. Inverse of inverse of resistance is known as conductance, but inverse of resistivity is known as conductivity. Okay, and it is denoted by the symbol small k. So conductivity is equal to 1 by rho. Okay, so R is equal to rho L by A, or you can also write rho R is equal to 1 by K into L by A, because rho is equal to 1 by K. Okay, so resistance is equal to 1 by K into L by A. What is the unit of conductivity? Unit of conductivity is SI unit is Siemens per meter, that is Siemens meter inverse, or in SCGS you can also write Siemens centimeter inverse. Okay, so after rearranging this equation, you can also write specific. You can also write conductivity is equal to conductance into L by A. Conductivity is equal to conductance into L by A, where L by A is known as cell constant. This L by A, cell constant means L by A is known as cell constant. So the relation between conductivity, conductance and cell constant, the conductivity, conductance and cell constant is conductivity, that is K, is equal to conductance, that is capital G, into cell constant, that is L by A. Now see how to calculate resistance and what problem you will face during calculation of resistance or measurement of resistance. For measuring the resistance of an ionic solution, there are two problems. Firstly, passing direct current changes the composition of the solution, and secondly, a solution cannot be connected to the bridge like metallic wire or solid conductor. These are two problems. For measuring these two problems, you will face during the measurement of resistance of an ionic solution. Now see what is conductivity cell. So conductivity of such solution, electrolytic solution, is measured in special type of cell which is known as conductivity cell. And a conductivity cell is consist of two platinum electrode coated with platinum black, and for this conductivity cell you can apply this relation for calculation of resistance, that is R is equal to rho L by A, where L is the length or distance between two platinum electrode and A is the area of each electrode. Okay, and I have told that this L by A is known as cell constant. And what is the unit of cell constant? That is L means centimeter per centimeter square. So the unit of cell constant is centimeter inverse. Okay, remember that. Now see different types of conductivity. You can express the conductivity of solution in different unit. First one is molar conductivity, which is represented by lambda m. Okay, so what is molar conductivity? It is defined as the conducting power of all the ions produced by dissolving 1 mole of an electrolyte in a solution. If 1 mole of an electrolyte is present in a solution, then the conductivity of the solution is known as molar conductivity. Okay, if 1 mole of an electrolyte is present in a solution, then the conductivity of the solution is known as molar conductivity. So molar conductivity, lambda m, is equal to the relation between molar conductivity and normal conductivity, that is K. The relation is lambda m is equal to K into 1000 divided by m, where m is the molarity of the solution. So relation between molar conductivity and conductivity is normal conductivity, that is lambda m is equal to K into 1000 divided by m, where m is the molarity of the solution. And the unit of molar conductivity is Siemens centimeter square mole inverse. Now second type of conductivity is known as equivalent conductivity. Equivalent conductivity, it is represented by lambda E. Okay, so what is the definition of equivalent conductivity? It is the conductivity of all these ions. It is the conductivity of all the ions produced by dissolving 1 gram equivalent of an electrode it is the conductivity of all the ions produced by dissolving 1 gram equivalent of an electrolyte in solution. Okay, so conductivity of solution containing 1 gram equivalent electrolyte is known as equivalent conductivity, and it is represented by lambda E, and its unit is Siemens centimeter square per gram equivalent. Siemens centimeter square per gram equivalent. All these definitions and unit of molar conductivity, equivalent conductivity, you have to remember, and you have to solve the some small numerical problem based on these formulas. Okay, so what is the relation between equivalent conductivity and simple or specific conductivity? K is known as conductivity, it is also known as specific conductivity. Okay, so the relation between equivalent conductivity and specific conductivity, that is K, is lambda E is equal to K into 1000 divided by N, where N is the normality of the solution. N is the normality of solution. Okay, so the relation between molar conductivity and specific conductivity is lambda M is equal to 1000 K 1000 divided by M, where M is molarity, and the relation between equivalent conductivity and specific conductivity lambda E is equal to K into 1000 divided by N, where N is the normality of the solution. Now see variation of conductivity and molar conductivity with dilution. That is how the different types of conductivity of an electrolytic solution varies with dilution. Conductivity generally decreases with decrease in concentration. This is because conductivity of a solution generally decreases with decrease in concentration. This is because the number of ions per unit volume of solution decreases on dilution. Okay, as the number of ions per unit volume of the solution decreases with dilution, therefore normal conductivity or specific conductivity decreases with dilution. Now see molar conductivity. How molar conductivity varies with dilution? Molar conductivity increases with decrease in concentration, that is molar conductivity increases with dilution. This is because the total volume of the solution containing 1 mole of electrolyte is also increases, but the number of particles in the solution remains same, because only volume of the solution increases but number of particles is also is 1 equivalent. Okay, still 1 equivalent. So molar conductivity increases with increase in dilution, that is with decrease in concentration. When concentration approaches 0, the molar conductivity is maximum. Molar conductivity of a solution is maximum when the concentration of the solution is approaches to 0, and this conductivity, molar conductivity, when the concentration approaches to 0, this conductivity is known as limiting molar conductivity. Limiting molar conductivity, which is represented by lambda m 0. Okay, so specific conductivity of a solution decreases with increase in concentration with increase in dilution, but molar conductivity increases with increase in dilution, that is with decrease in concentration. And graphically you can also show the variation in conductivity, molar conductivity of different electrolyte, of strong electrolyte and weak electrolyte. I have told that conductivity of a solution, molar conductivity of an electrolytic solution generally increases with dilution. And for strong electrolyte, the variation is like this straight line. With decrease in concentration, the conductivity of the solution increases. And for weak electrolyte, if you decrease concentration, if you dilute, increase the dilution, that is if you decrease the concentration, the conductivity of weak electrolyte increases exponentially. Okay, so this variation is this curve is for weak electrolyte like acetic acid, variation in molar conductivity with concentration on dilution. Okay, and with increase in dilution, that is with decrease in concentration, the conductivity of strong electrolyte increases linearly. Okay, so for strong electrolyte you can calculate the conductivity of a strong electrolyte, the limiting molar conductivity when concentration is almost 0. This then the conductivity, molar conductivity is known as limiting molar conductivity. Okay, so from this graph you can calculate conductivity of strong electrolyte at zero concentration, almost zero concentration, and this will be the maximum value of molar conductivity for that strong electrolyte. Okay, and this conductivity is known as limiting molar conductivity. Okay, so next day again I will discuss. Thank you, students.